Hello everyone. So in this lecture, I'm going to talk about sine rules and cosine rules. They are properties of triangles. So we study triangles in depth because trigonometry is based on triangles. So finally we have to connect all the things, connect all the dots to the geometry. We started with geometry. That means we used right angle triangle to define certain ratios. That is where we started this, and from that we talked about different things, the formulas, and we expanded the definitions to any angle. So we learned about quadrant rules, and we learned how to express any angle using an acute angle. Then we talk about double angles, compound angles, and sum product rule, product sum rules, and everything. So these formulas were studied during this course, and then we looked into solutions of trigonometric equations. So everything is covered up to now is based on the algebraic part, or the analytical part of the trigonometry, and we started from the geometry, and we're gonna learn now how everything is connected to the geometry again. Right, so this would be the sixth lecture. We have already uploaded 5 videos with regard to trigonometry. So I didn't upload any videos for a moment, because in those videos we only had to learn about formulas and how these formulas are applied. So the derivations were discussed during the class. So there's nothing new. What you have to do is you have to remember the formula and apply them into identity solving problems. Right, so the sine rule. So what is sine rule? If you have a triangle like this is a general triangle I have sketched here. First of all, you have to specify the angles and the sides. So this is how you specify a triangle. So you name the vertices anti-clockwise. You start from A, B, C. So whatever the letters are, it should go anti-clockwise. A, B, C. And the opposite to A vertex is this side. So this side is named as simple A. And opposite to this angle, the side is named as simple B. And the side opposite to this angle is named as simple C. This is how you name a triangle. So this is an agreed way of naming triangles. You have vertices, you have sides. Now what about the angles? You know, in a triangle you have 3 sides and 3 angles. So the angles are referred to by the specific letter at the vertex. So this angle is A, this angle is B, this angle C. If we have a triangle like this, the sine rule says that this ratio is always consistent. This ratio is always consistent. That means A is a side is given in meters, centimeters, or anything. A divided by sine of A. Simple A divided by sine of angle A is equal to simple B divided by sine of angle B is equal to C divided by sine of C. So this is consistent. It doesn't matter where you sketch this triangle. If you sketch it in Sri Lanka or USA or at the end of the universe, this ratio holds true. This is always true for any triangle. So in general, this is a ratio. So the ratio will have a certain value to it. Sine A, B over sine B, C over sine C. Let me call it K. So K is the value of the ratio. Right. So we have to prove this. I'm going to prove it now, and we will prove these relationships in this video, and we'll look into how these are applied into problems during the sessions. Right. So how I'm going to prove this is that I'm going to use, I'm going to try to construct right angle triangles within this general triangle. So let's see how it is done. So let me take this dashes. Right. Now if I draw a line, like this, such that this is perpendicular. So let me call this D. This point is D, and the length is C. So let me just write it somewhere here. This is the length AB. This is the point D. So CD is constructed such that CD length is perpendicular to AB length. This is how it is constructed. So when I made this construction, I know that using these properties of right triangles, I can write CD can be written using this triangle. You can see that ADC using this triangle you can write B. So you can, let me write it this way. AC means this side, sine A. AC sine A is equal to CD. So AC is B sine A. This is equal to CD. And using the other triangle, we can write CD in terms of A and B. So this would be CB sine B. So CB means A sine B. Now CD is the same side, so these two are equal to each other, which gives me this relationship: B sine A is equal to A sine B. So this means that A over sine A equal to B over sine B. Right. So likewise we can select another side. So let me do it. I'm gonna make another construction. Let me take this side. So if I constructed side like this, which is perpendicular to AC, so let me name it. Let me name it DE. Right. So in this case, BE is perpendicular to AC. Now using these two triangles, now I can write the same relationship. So A sine C is equal to BE. If you use this triangle, AB sine A equal to EB. AB means C. So C sine A is equal to BE. Since the left side is equal to each other, so I can write A sine C equal to C sine A. Then A over sine A equal to C over sine C. You can see that B over sine B equal to A over sine A. Also A over sine A equal to C over sine C. This tells us that B over sine B is equal to C over sine C. Right? That means all these ratios are equal to each other. So finally I can write A over sine A equals to B over sine B is equal to C over sine C. So all these ratios are equal to K. Let me call it K. So usually you write this relationship. If you write this relationship, you can figure out certain parameters of this triangle. Suppose A, C and A is known. A, C and A is known, and you are asked to find what the angle C is. Right? You can use this relationship. Right. So what you have to know is that these ratios are equal to each other, and they are all equal to a certain ratio called K. So suppose in a problem based on a triangle, you can write A as k sine A, B as k times sine B, C as k times sine C. So when you write it in this way, A plus B plus C can be written as k times sine A plus sine B plus sine C, right? So A plus B plus C is equal to sine A plus sine B plus sine C. This is equal to k. Right? So you don't have to memorize this relationship actually. So this is a way that you can apply this relationship in problems, and we'll look into the problems in the discussion itself. Right. So this is about sine rule, and we'll look into cosine rule now. The same way, cosine rule says that